Hello friends, welcome to Chemistry Nuggets where you can polish your knowledge and clear your doubts. Friends, today's video is 10th part of the Thermodynamics Chemistry class 11. In this, we are going to understand the reaction enthalpy. So, let's start quickly. Reaction enthalpy, which is denoted by delta subscript R for reaction and enthalpy H. Now, the change in enthalpy accompanying a reaction is called reaction enthalpy. It is very simple. When we are going through a reaction, there is a change in enthalpy. That change is called the reaction enthalpy. Now, what is the use or why we are going to study about this? There are two very important uses. First thing, with the help of reaction enthalpy, we can understand whether the reaction is possible or not. So we can know, does the reaction is possible or not. Second more important point is, if the reaction is possible, then how much heat is required to start the reaction? How much heat required to start the reaction? So these 2 points are very useful when we are going to industrial chemistry. We have to perform any reaction, any new thing we are going to start. So we should want to know the idea whether that particular reaction is possible, or if we are going to start, how much starting heat we should apply. So friends, so there is a small calculation to calculate the reaction enthalpy. So suppose we have a reaction A plus B. Here the A and B are the reactants and products are C and D. Now, so reaction enthalpy is the sum of enthalpies of the product minus sum of enthalpies of the reactants. It is written as summation means sum AI H product minus summation Bi H reactants. Here AI and Bi, these are the stoichiometric coefficient. Coefficients. So what is that actually? Stoichiometric coefficients. We have already studied when we are going to do any reaction, we write some reaction, we have to balance the reaction, or in simpler way we can say the amount of reactants and products which are in use in those reactions. Those coefficients are called stoichiometric coefficients. Suppose in this given reaction, A is the amount of reactant A, small b is the amount of reactant B, small c is the amount of product C, and small d is the amount of the product D. So here A, B, C and D, these are the coefficients and these are all called as stoichiometric coefficients. Let's have a real life example to understand better. We have a reaction where methane reacts with oxygen, or we can say methane CH4 in the gaseous form combines with oxygen which is in gaseous form, and it gives the product carbon dioxide gas and water as a liquid. So in this reaction, if we are going to calculate the reaction enthalpy, first of all we need to balance the reaction so that we can get the stoichiometric coefficient. So to balance this reaction, we have to add 2 here and 2 here. Now this reaction is balanced. Let's start to calculate delta RH. Is it sum of the enthalpies of the product. So here products are carbon dioxide and water. So enthalpy of CO2 gaseous form plus enthalpy of water in liquid form. Now water having 2 moles, so we can write 2 here, and carbon dioxide 1, so need not to mention. Now minus enthalpy of the reactants, enthalpy of CH4 gas plus enthalpy of oxygen gas. Now here oxygen it's 2 and methane is 1. So 1 need not to mention. Now this is the way we can calculate the reaction enthalpy. Now let's come to next point, standard enthalpy of reaction. It is denoted by delta H and this is superscript, a circle and a slash mark. Now we can denote standard enthalpy of reaction like this. The enthalpy change for a reaction, as we already studied, when all the participating substances are in their standard states. Now what does this term means? Standard state. So same things, enthalpy change in the reaction, but now here the substances means reactant and products should be in standard state. Standard state means its purest form at 298 Kelvin and 1 bar pressure. That is called standard state. For example, pure ethanol is at its standard state will be at 298 Kelvin and 1 bar pressure. At this condition, if we get the ethanol, that will be a purest form and it is called as a standard form. In the same way, for pure solid iron, we'll get it at 500 Kelvin and 1 bar pressure. This is the purest form of solid iron and at this point it is called standard state of solid iron. So friend, you understand? In reference, most of the time we take the standard state at 298 Kelvin. So don't get confused. Let's next point is enthalpy change during phase transformation. Now what is phase transformation? Phase transformation means from solid to liquid change. It is called fusion, or we can say from liquid to gas. It is called vaporization, or one more is solid to gas direct. It is called sublimation. So what is the energy change or enthalpy change when there is a phase transformation? That we will study now. So first of all, we will study about standard enthalpy of fusion. It means from solid to liquid. When there is a transformation from solid to liquid, the enthalpy change that accompanies melting of 1 mole of solid substance at standard states. So as I told, standard state means at 298 degree temperature and 1 bar pressure. And now one more thing is added, 1 mole of that substance. So if the condition is like that and the transformation is there, phase transformation is there, then it is the heat required is called standard enthalpy of fusion. It is denoted by delta subscript fusion FUS and H standard sign. Now if there is a transformation from solid to liquid, it means heat is applied. So we can say this is a endothermic reaction. Second most important point is, if the reaction is heat is given, it means the standard enthalpy of fusion will always be positive in nature. Because heat is given, it means there is an increase in energy, so it will be positive. Now, so you understand phase transfer from solid to liquid. Come up to the next point, standard enthalpy of vaporization. It is denoted by delta vaporization VAP subscript and H standard. Now, the enthalpy change that accompanies vaporization of 1 mole of liquid substance at standard state. Again the same thing. Standard state means temperature should be 298 Kelvin, pressure will be 1 bar, and here one more thing added, 1 mole of the substance. The substance quantity is also fixed. Now, in this condition, when there is a phase change from liquid to gas, so we need to apply some heat. That amount of heat is called standard enthalpy of vaporization. So, it is first thing endothermic reaction. Second point, it is positive in nature because heat is given. Next is standard enthalpy of sublimation. It is denoted as delta, subscript में SUB sublimation and H standard form. Now the enthalpy change when 1 mole of solid substance sublimes at standard state. Correct? So it should be 1 mole in amount, temperature should be 298 degree Kelvin and the pressure should be 1 bar. In that condition, if solid converts to the gas, then the amount of heat required is called standard enthalpy of sublimation. Okay, it is endothermic because without giving energy we can't transform from solid to gas. So it is endothermic reaction. Second point, if it is endothermic or heat is given to the reaction, then the enthalpy will be positive in nature. So friends, till here we understand about the reaction enthalpy, everything about that. Now one more point to mention here is, what is the magnitude of the reaction enthalpy? Or we can say how we can determine whether the magnitude is big or less. What are the key points? The key point is when there is a phase transformation. It means between the particles there is strong intermolecular force. So the stronger the force between the particles, the bigger the magnitude of the reaction enthalpy. So more force, more intermolecular force. So main point is here intermolecular force of attraction between the particles. The lesser the force or the weak intermolecular force, it means the change is easy and the magnitude of the enthalpy is low. If the intermolecular force is strong, it means the applied energy will need a big amount of energy to break that force. So friends, that's all for today in this video. Reaction enthalpy is explained nicely here. If you have any doubt, please go in the comment section and write it there. I will definitely come back to you. Till then, thank you. Keep like and share subscribe the channel.